Hello everyone. In this video, I will explain a method to find direction of induced current. I hope you know Lenz law, statement of Lenz law, but I will explain Lenz law in a different way. So, for example, if in a loop, if EMF is induced because of increase in magnetic flux, then induced magnetic field will oppose the external magnetic field. If in a circuit or a loop, if EMF is induced because of decrease in magnetic flux, then induced magnetic field will support the external magnetic field. I'm using two words. One is induced magnetic field induced by the induced current. Another one is external magnetic field. Okay, so we know that from the elementary physics that a current carrying loop, whatever may be the shape, is equivalent to a small bar magnet. Now we know that from right hand thumb rule that this kind of current loop produces magnetic field out of the page. Correct? Thumb, if you curl your fingers like this, then thumb points out of the page. And we also know how magnetic field lines looks like around a bar magnet. And it appears that from the North Pole, magnetic field lines uh, goes out of the North Pole of the magnet. So therefore, if you have this kind of a current loop, if you look at this from the top, you will see North Pole. Similarly, if there is a clockwise current, then the magnetic field is into the page. So therefore, if you look at the slope from the top, you will able to see South Pole of the induced magnet. This is an induced magnet. Similarly, if you have current like this, curl your fingers like this, magnetic field goes like this, so therefore the North Pole is here. And if you look at this one, what what is the position of North Pole? Again, if you curl the fingers like this, North Pole will go like this, so therefore this is equivalent to a magnet of this kind. Correct? So anti-clockwise current means North Pole out of the page, clockwise current means North Pole is into the page, or you will see the South Pole. So based on this, let's try to solve 2 3 problems here. So look at this, I have already drawn the direction of induced magnetic field. So here, look at this. So here, because North Pole is moving towards this loop, the external magnetic field direction is this, going downwards. Correct? Because magnetic field comes out of the North Pole. So this is external magnetic field. As the magnet is approaching this loop, magnetic flux through this loop increases. And as I said earlier, here EMF is induced because of increase in magnetic flux. Therefore, the induced magnetic field should be opposite to this external magnetic field. To get magnetic field in this direction, current should go like this. And in other words, should have North Pole here. Correct? So therefore, North Pole opposes North Pole. Similarly, look at this. Here, magnet is going away from the loop, so therefore flux decreases. Correct? But what about the direction of external magnetic field? This is the direction of external magnetic field. Here, flux is decreasing. Flux is decreasing here. So therefore, induced field should support the external field. For that, you should have South Pole here and North Pole here. How to have this kind of induced magnet? It means you should have current like this. Correct? So therefore, induced magnetic field is supporting the external magnetic field. Look at this. Here, South Pole is moving towards the coil, but the direction of external magnetic field is this because North Pole is here. Since the magnet is approaching this loop, flux through this loop increases. So, induced magnetic field should oppose this external magnetic field. That means you should have this kind of induced field. In other words, you should have south pole here, north pole here. Again, the same situation. So you'll get current, induced current direction like this. And if you look at this, if you look at this here, flux is decreasing because magnet is going away from the loop, and direction of external magnetic field is this. So flux is decreasing, and hence the induced magnetic field should support the external magnetic field. So this should be the direction of induced magnetic field, correct? In other words, you should have north pole here and south pole there, correct? So the situation is similar to this, correct? Or in order to have north pole of this kind, so you should have current like this. Use right hand thumb rule, so you'll get magnetic field in this direction, correct? Fine. Now look at this problem. So here I have two loops A and C. So let's find out the direction of induced current in A and C. A is entering into the field, magnetic field. Magnetic field is into the page here. So as A enters into the magnetic field region, flux through A increases, correct? So here EMF is induced because of increase in magnetic flux. So therefore induced field should oppose this external field. So external field is into the page. Induced field should be out of the page. That means upward. In order to have that, you should have current in this direction. Correct. Field is out of the page. What about this? Here the loop C is going out of the magnetic field region. Correct. So here flux is decreasing. So therefore induced field should support the external field. That means magnetic field should be into the page. So in order to have that, we should have magnetic field like this into the page. Now look at this situation. So here there is a magnetic field. There is a magnetic field which is coming out of the page, and there is a loop whose size is increasing. This arrow mark indicates the size of the loop is increasing. So here again flux increases. So therefore induced field should oppose the external field. So therefore induced field should be into the page. How to have induced field into the page? That means you should have current like this, correct? So this kind of current produces magnetic field into the page. Now look at this case. So here current is increasing in this wire. What is the direction of induced current here? So first use right hand thumb rule to find the direction of external field. If you have this kind of current, hold your thumb in this direction, then in this loop magnetic field comes out of the page. So direction of external field is out of the page. As current increases, B also increases, and hence flux increases through this loop, correct? Therefore induced field should oppose this external field. So in order to oppose, induced field should be into the page. So therefore current should be like this. Now look at the similar situation here. Here again, because current direction is the same, direction of magnetic field here is the same again. But current is decreasing, so field decreases, so flux decreases. But induced field now, because flux is decreasing, induced field should support this external field. So for that, current should be like this. Induced current should be like this. Correct. Fine. Look at this situation here. Here there is a loop of an arbitrary shape, but magnetic field is into the page. B is increasing magnetic field. So B is increasing, and hence flux through this loop increases. Therefore, induced field should oppose this external field. So that means direction of induced field should be out of the page, correct? So therefore, this should be the direction of induced current. And look at this problem. This is from NCRT. The question is, what is the polarity of this plates of a capacitor? So here again, there are two magnets approaching the loop. So when two magnets approaches like this, flux through this loop increases, correct? So therefore, uh, induced magnetic field should oppose both of these. That means here you should have, on the left you should have north pole, on the right you should have south pole, like this, north and south. In order to have north in this direction, should have current like this. So therefore, apart from this capacitor, the remaining part of the loop behaves like a small battery, like this. And this, now you can imagine, there is a battery and a capacitor. So positive of the battery is connected to plate A, and hence polarity of plate A is positive and B is negative, correct? So only idea is this one. This produces magnetic field out of the page and thus into the page. This to the left and this to the up, like this. Okay, I hope this video will help you to find the direction of induced current. Thank you.